Okay, I think we should get started. So we all owe a great deal of thanks to Jacob from Math for first taking over the professional development workshop series. We did this last year too, a series of 7 workshops, and the GSD looked at all the evaluation that we got from those workshops and then picked which ones they wanted to do. The first series, the grad school, in addition to Dave and a few other people, Dave Shauner, started the series. And we felt now, after having done it once, it might be good to get the grad student government more involved in this so they can help us guide which workshops they want and how to reach out to their student population, their audience, rather than the grad school running it. And so that's why this year the GSG has been doing a lot of work to get the series. So Jacob, thank you. Thank you for this. So this is the first of our series of 4 or 5. So please let others know they put in a lot of work to make what they think is the best workshops possible. If it's not useful, please give them feedback, give us feedback, because it's meant to serve your purpose. Okay, so with that introduction, let me introduce myself and the other panelists today. I'm Pushpa Murthy. I'm Dean of the Graduate School. I'm a chemist, a professor in the chemistry department. I've been here for 30 years at Michigan Tech, and now been Dean of the grad school for 2 years now. Then Lynn Mazzolini, professor of chemistry. Lynn, I'll let you introduce yourself. I have a little blurb here.
Okay.
From you.
Okay. I'm not going to read it.
No.
So I'm an associate professor in chemistry. I've been here at Michigan Tech just about 10 years now, and I'm also running the Charm Lab down at the GLRC, thanks to a grant from NSF. And my research area is really environmental science. I study atmospheric aerosols. If you don't know what that is, that's okay. But fundamentally, really complex stuff, lots of data and lots of writing. So I'm happy to talk about writing here today.
Right. And in thinking the panelists, what Jacob and I were trying to do was pick faculty. There are many faculty at Michigan Tech who have active research programs and who write along with students. However, we had to pick a few. So we looked for faculty we knew were actively publishing and working with students and have student co-authors, and we just kind of semi-randomly picked 3, but you're all working with faculty are also publishing and working with you. So that's how we ended up being here. So second panelist, Will.
My name is Will Cantrell. I'm a professor in physics, and as of about a week ago, I'm also an associate dean in graduate school. I've published papers with as few as 1 other person and as many as 49 other people. And I'm happy to talk about that process because those 2 experiences can be quite different. And understanding how you navigate that can help going into it. I've also reviewed, so I have that perspective as well, for publications ranging from discipline specific, like Journal of Geophysical Research in my area, but I've also reviewed for other more widely disseminated journals like Proceedings of the National Academy of Sciences. And so I can talk to what reviewers are looking for when you submit, as I'm sure the other panelists can as well.
And I'm David Shauner. I'm the engineer here, surrounded by distinguished scientists, and so I feel very intimidated.
Right.
I've been here since 1993, so 25 going on to 26 years. I'm also the director of the Sustainable Futures Institute, which is a multidisciplinary research institute here at Michigan Tech. So I've worked with faculty from almost all departments and schools and colleges on campus. So that's been a very enriching experience, and I've published with many of them as well. So I can talk about the interesting challenges in publishing across disciplines, if that's of interest to folks. And I'm also on the editorial advisory board of the ACS journal, Sustainable Chemistry and Engineering. So I have some experience with editorial activities. And I've also been an invited special editor for a series of articles in another journal. So I have some experience in that level of editorialship as well.
Okay, so you see, we try to get the spectrum of people who have worked with students, published as well, and then, as well as being on the editorial board, editor, associate editor, asking for reviewers, all of that stuff. So you'll get to understand the whole process, the entire process from when you feel you should start writing to what do you do if it is accepted, what do you do if it's rejected, what do you do until the process is over. So we're going to cover all of those things. Before we start that, what I'd like to do is for us to get to know you, so we know which areas you're in, and for you to know each other as well. So what I'd like you to do is to tell us your name, tell us which department, discipline, program you're in, and third year, fourth year, second year, where are you in the program, and why you thought you would like to come to this workshop. Just a few minutes quickly, if you can go through the room, so we get an idea of who the audience is we're talking to. That would be useful as well. Yes, who wants to start?
Yeah, I can start.
Good.
Okay. So my name is Toyin, and I'm a first year student in the chemical engineering department, and I'm getting my PhD. Actually, attending this training because I would love to have 3 papers before I'm done with my PhD. But I think we would need to know what it entails and all of that. Yeah.
That's excellent. It's excellent that as a first year student you decided to come. Because sometimes people put it off for too long. It's good to know the whole process at the beginning than later. So glad to have you here. And if you want, you can sit here so you can see all the audience also.
Okay.
And please feel free to get up and help yourself to some drinks and food whenever you want to. Okay? This is a very informal session, so feel free to do that.
Hi, I'm Omkar Zaveri. I'm in 6th year of my computer engineering, hopefully the final year. As of now, I have a publication as a co-author, not a first author. And I plan to submit a publication this November. So I want to be well prepared for everything what's coming. Thank you.
Thank you.
I'm Ali, first year student in the master student in electrical engineering. I'm just interested how to write paper. I don't have any background knowledge about it.
Good. Welcome. Yes.
My name is Muhammad. I am a PhD in mechanical engineering. This is my second time. This is my second year here, and I published 3 papers, and I have also 3 under review right now. But I came here because actually one of my research points are resisted out from the reviewer, so I need some advice. This is all.
Good. But it's never too late to learn and to learn more about this. We've published many times, many of us, but every time you submit one, it's still a new process. It's a new journal, new editors, new reviewers, and how to respond. So every paper submission is a learning experience. So it's good to have a spectrum of people. Yes?
My name is Peter. I'm a second year in the material science department getting my master's, and I'm going to be publishing soon, so I thought this would be a good thing to come to.
Hello everyone, my name is Injit. I'm in the Department of Bioengineering and Biology and Geophysics. And I just did my first year master's, so I want to start thinking about concepts writing this for next.
Very good. Very good. It's good that some of you are beginning your graduate career and already thinking about these things. That's excellent.
Hi, I'm Chandra. I'm a second year PhD student. I am from chemistry department. I haven't published anything yet, but these days I'm working on 2 research papers, so I expect to publish them soon. So I thought that it would be better to be here, get some understanding about it. Good afternoon, everyone. I'm Ronnie. I am here, first year PhD student doing my PhD in computer engineering under Professor Murthy. Before coming here, I've published a few papers as co-author, as first author as well, but I'm here to know more about how to write a good manuscript, as well as the whole, to understand the whole publication process for that.
Hi everyone, I'm Shane, and I'm from the chemistry department. And I work in the school, and this is my last year. Yeah, because I just checked online and I found this. We have this.
And Jacob, what about you? Introduce yourself, Jacob.
Hi everybody, I am Jacob Brzezinski. I am entering my 3rd year in the Mathematical Sciences Department for a PhD in Applied Mathematics.
Good. Okay, so the way we're going to do this is, I wanted to make sure that we cover the entire process from beginning to end. So the slides are there to help me make sure that we go through the process. But what you will find is that each one of us has a different way of approaching this. Each one of us, 4 panelists here, has a different way of approaching it. Depends on the discipline. Even within chemistry, whether you're a physical chemist, organic, inorganic, analytical, it's a different way of writing. It depends on the journal. Even in your own field, depending on which journal, you will have to look at what they're asking. Some journals have just communication, some journals have communications and papers, and how do you write that? That's all different. And each student and their writing ability is also different. Some of us write well, easily, and I wish I could say the same for myself, but no, I struggle and go through many drafts for no matter what I'm writing. So it depends on the student, it depends on the advisor, how they work with the students and get them to publish in the most efficient, effective way possible, you know? So there's no one good way to do this. There are many ways to do this. So the 4 of us do it differently. And so for most of the things that I say, you may find 4 different opinions on that. So the panelists, whether it's Lynn or Will or Dave, will say, yeah, but this is the way I do it. And so you have to find out what works for you and then do it.
Pushpa?
Yes.
Can I suggest we turn this off so we can hear you, and then we can turn it on later?
All right.
Okay. So the presentation won't be.
You can read about that. That's good. Yes. Oh, it's making a record.
It's really putting out.
Yes. It was making a lot of noise. Yeah. So strive for language perfection. For many of us, English is not our first language. On the other hand, even for people for whom English is the first language, writing in the discipline is not a first language. So we all have to learn how to write in the discipline. So it's a challenge, no matter English is your mother tongue or not, you know. So, and you need to strive for that. I don't know how many papers I have rejected because I said the English is so unacceptable that we can't figure out what they are saying. So I didn't even get beyond that. I read the first 2 pages. I don't know what they're talking about, what they're trying to study, what they mean when they say some things. So many papers just get rejected right off. Have you rejected papers because they said, the English is so bad, I can't follow this?
Occasionally.
Yeah. I rejected so many in a year. This was a journal of biochemistry and molecular biology. I thought they were sending me all the papers that they had English with, so I would reject it, you know. It was too many that I was rejecting. They didn't want to do it, so they were sending it to me, I thought. So, yeah, really, expect to be rejected, okay? It's not personal, don't take it personally, and we'll talk about what we do when we do get rejected. If not, if they say submit with minor revisions, boy, you're already there. I think.
Yeah, I was going to say there's different levels of rejection, right?
Yes,
There's
good, go ahead.
reject and don't submit again ever. There's
Ever.
reject and don't submit this paper to me. There's reject and major revisions. There's reject with minor revisions, and so there are different levels of rejection. But Dr. Murthy is right. It's very rare to get your paper just accepted without any changes.
Right,
I mean,
because
it's maybe it happened to me once in my career. Out of 100 papers, maybe, I think it happened once.
right, because when they, what you have to keep in mind is when they accept, they are saying accept the paper the way it is right now. Almost never happens, right? So then different journals will say, if you can't accept it the way it is right now, you have to send it back for corrections. They can call it accept with minor revisions or reject with minor revisions. So the terminology depends on the paper, or accept or reject with major revisions. Then you know you're accepted, but you really have a bit of the work to do, maybe an additional experiment, maybe whatever it is, right? Accept with minor revisions or reject with minor revisions, that's great, you're almost there. So that's a good thing. But if they say reject and don't ever submit again, they will not say that, but they'll say, oh, it doesn't align with the mission of the journal, all of that stuff. There are different nuances you have to read between the lines, and we'll talk about some of that as we go along. So expect to be rejected. And you know, the nice thing about paper compared to writing a research proposal is, even if you're rejected, you can go back and you will get accepted. So long as your work is good, in some journal or the other, you will get accepted. Research proposals, on the other hand, you may never get accepted. So papers are much easier because pretty soon you should find, if you're doing good work, you'll find the right journal and it will be accepted. So that's the way I go into this whole process. Yeah, if you're rejected, make changes and resubmit. And we'll talk about what changes and what they're talking about. Yeah, so why do we do this entire peer review process in the sciences? First and foremost, it is to ensure that your work is good, scientific integrity, that you follow the right methods, you've used the right controls, you've drawn the right conclusion, all of those things, and we want an independent pair of eyes to be able to, one or two or three pairs of eyes to be looking at it and saying, this is good science. Basically, that's what we want to do. This is reproducible, this is good science. In addition, it's also, you know, almost every journal will say, is this relevant work? If you want to prove that the earth is round or flat, that's not relevant work. That is accepted science. So is the work relevant to this time in your discipline? That's the other thing they're looking at. Ensure that the quality of the transmission of scientific information. Are you presenting it in a way that others can follow and reproduce what you are doing? So that's usually one thing that reviewers are looking at. Can someone else look at your method section and be able to reproduce it and understand, get the same results that you are getting? Reproducibility. Part of it is that, and part of it is people, the next generation should understand, what is it? What is the scientific information, new information you're transmitting? And really the whole process of peer review is to make your work better. And I would say 99% of the time, it makes your work better. Things that you didn't see, you overlooked, you forgot, some others will pick it up and send it to you. Lynn, what do you say? Yeah?
Yeah, so I just want to say that it's always hard to read the reviewer comments, especially if they are not written in a very nice way. Some reviewers are really a little bit too harsh sometimes. Most of them aren't. Most of them are really quite fair. But every once in a while you'll get somebody who just really doesn't have much tact. And if they're really picking at a sore spot already, that can be really irritating. But after you get past that emotion and actually address the comment in a nice way, usually you feel actually really grateful that they pushed you on something that you actually didn't want to be confronted on. So in the end, you will be very grateful. but there will be a lot of pain and suffering along the way.
Right. And which is also a lesson to us as reviewers, because pretty soon you'll be doing that too. You'll be on the other side of this whole process and writing reviews that do it in a way that is constructive and that they can learn something from it, rather than, oh my God, this is so horrible, I can't understand. That's how you're feeling, but please be careful how one conveys that information as well. So it really does make your work better. I said 99%, it could be that 1% where you can't get past, but yeah. And also, this is the peer review thing is a measure of your scientific productivity, your creativity, your ability to solve problems, right? That is the currency that we use in the scientific field. So whether it is to get in the scientific research enterprise to say, how productive have you been? What's your ability to define a problem and address it creatively and well? And what is your ability to communicate that information to the rest of the scientific community? That is paramount for us as researchers. And so peer-reviewed publication is what they look at for, offers, promotion, tenure, and all of those sorts of things. Any other comments? Yeah. So let's look at the process here. Let's step back and see. So, of course, so this is your manuscript you have written. We'll come to writing the manuscript in greater detail. Then, and how you pick a journal, we'll talk about that also. This is the overall picture. You're then submitting, you finished your manuscript, you submit to the main journal office. These days they're all online. Goes to the editor-in-chief, who then sends it to associate editors. Usually you will see in the journal, right, list of associate editors. Sometimes they're defined by areas and things. You've read like hundreds of papers by this time in your field. So when you flip the journal, you will see all of those things, right? So that's where it goes. It goes to the editor, who then sends it to the associate editor. This process is different for different journals, and we don't need to really get into that in that much detail, but that is what happens there. So then the associate editor usually is then going to decide which reviewer to send it to. 1, 2, 3, 4, 5. What role does the associate editor themselves play? Because they are also going to read your manuscript and then make a decision where they're going to send it to. So how much does their evaluation of your manuscript count? All of that is behind the scenes, and often we don't see what is happening there. So this you send it. When you say it's been submitted, it's in review, this is what you're saying, right? It was received. They did a compliance test. The font size was right. The figures were good. All of that stuff happened. And it's gone to the reviewers, to the 3 reviewers. And then you wait to see when you'll get the reviews back.
They also do the plagiarism check
Oh
quite
yeah,
frequently
these
before
days
they'll
they
even send it for
do.
review.
Turn it in or different thing to see if there is plagiarism. Yes. One of the things for many of us you're looking at is how quickly will this paper come out? That is one thing you're looking at, right? Because will it take 6 weeks? Will it take 6 months? Will it take 1 or 2 years? And sometimes you want the paper to come out soon, especially if you're looking for a job or a postdoc or whatever, or weighing up for tenure, whatever the case may be. So sometimes the journals will tell you, expect, from the date of submission, blah, blah, blah. They can't really be ever totally sure because it depends on how many back and forth and how many revisions you need to do before it is fully accepted. But they give you some time frame. Many of them, not all of them. But for me, a better way to gauge that is, once it's published, they always say submitted, accepted, and then you know when it's published because the journal will tell you, September or whatever the date is today, this is when it came out. And if you flip through like 10 or 15 papers and you see for me, I look at the difference between when it was submitted and when it was accepted, because they often tell you that. And then it'll tell you, even if it's accepted, how long is the time frame before it's actually put in print. These things are all condensing these days because we don't have to send it to the post office, but nevertheless you get an idea of how long are you talking about from the time of submission to this time of publication, assuming it's going to end up. Any pointers from you? And sometimes
I think you need to be careful in choosing a journal that the time frame is not overly long. There are some journals I simply won't submit to, or I won't have my students submit to, because my experience has been so negative in the past, waiting and waiting and waiting, not hearing from the editor, emailing the editor and not getting a reply, and all that time is slipping away. And it's especially bad for the students who, as Dr. Murthy mentioned, you're going to interview for a job and you need to show a good productive outcome on your resume. So that's something you need to be very careful about. And most journals will publish. If you look at publications, they will show on the first page the date it was submitted, the date it was accepted, the day it was in print, and you can add up that whole time. And if it's more than 6-8 months, you may not want to submit to that journal. So that's it depends on the discipline as to how long things get done. But in the engineering fields, if it's longer than 6-8 months, I don't even submit to the journal.
And I would add that 6 to 8 months is typical. I know that sounds like a long, you mean I've got to wait half a year between the time I submit this to the time that it's published? Yeah, 6 months is about the typical time that you have to wait, because most of the time the associate editor, so I can speak to this as a reviewer too, the associate editor sends it to the reviewer and says, we want this review back, and they give you a date, and it's usually a month. You have a month to do this. And so, and usually what happens is, then they have to pester you. Hey, you're overdue. I don't do this. I always submit my reviews on time.
None of us are ever delayed, right?
No, I'm
Every
late,
party.
but I'm definitely late.
I am too.
Yeah.
I really like it when they send a reminder 1 week before the deadline.
That's right.
Yeah, they're typically doing that now.
That's right.
Yeah.
That's what I was going to say. One of the ones that I used to write the review a lot for, in 2 weeks. So you say yes, within a week you're getting a reminder, which is good, which tells me, okay, I have a week, I better get my act in gear here. So I think many journals are doing that now. Your due date is a week from now, so they know we are this week. I'm like, unless you're like,
So this time,
well,
this time required depends on 2 things. One is how many submissions are coming to the journal, how much pressure is the journal under, and secondly, the role of the editor-in-chief and the associate editor. If they're not good editors, they will just let things languish, and that's really the role of the editor, is to make sure that things move along, and that they're communicating with the authors, because the authors are submitting to their journal, and they're not getting any. Nobody's getting paid for this. This is like, it should be a mutual benefit. The journal benefits from the scholarly output of the authors, and the authors benefit in getting their work disseminated. If it's not a good 2-way relationship, then it's a bad journal, and should be avoided.
Yeah. So that's why it's good to look at 10-15 papers in the journals you're looking at and get an idea, okay, 6 to 8 months. If they're all between 1 year and 1.5 years, then you have to rethink, really, is this something you want to? You may want to for different reasons, but you should be aware of it when you go. The other thing I want to take a minute and talk about here, and again, I want to get everybody's perspective. So how do you put this in your CV? And you put it different ways. Sometimes people will say, manuscript in preparation. Okay, it's good. You can put it, especially as a PhD student, but it really doesn't tell me if I'm evaluating you for a job anything. Okay, because the manuscript could be in preparation for 2, 3, 4, 5 years. Who knows what that really means? However, you can say manuscript in preparation, expected to be submitted by end of June 2019, whatever it is. So that gives me, if I'm evaluating you, a little bit more information. Not that I'm going to totally believe it, because I know how these things work, but nevertheless, I'm saying, oh, the work is probably mostly done, halfway done, and they're expecting that they're thinking of writing. Okay, so especially for PhD students, postdoc, once you go higher up, manuscript in preparation really doesn't mean anything, because I've seen some people whose manuscript was in preparation for 5 years. So that's what I mean. So, but you can list it that way, but because it is still conveying to the evaluator, to the selection committee something. Then you can say submitted for publication, right? Then it's telling them something completely different. It's saying it's done and it's submitted. So the work is done, you finish the writing, you've submitted. And if you're going to put that in your CV, it's good to send a copy of that or submit it on 1st June, 2018. So then they know it's gone and here's a copy if you want it. So it's real then, right? Then people will say submitted, or people will say in review, which means the same thing, that it was submitted on 1st June 2018 and it's in the review process. And the third way people list this is they'll say accepted, which means it's accepted but it's not come out in print yet. And you don't know when it's going to come out in print. Then of course we know we have gone through the review process, it's really accepted, this is going to come out soon, and you can send them a copy of that because they know this is the final form it's going to look. And then of course if it's in print, you don't have to do anything, you just can cite it and you're done. So those are different ways to let them know how much, where are you in finishing the project and publishing the project. But any comments? Any comments? Yeah.
So, say one journal, maybe I'm working on a journal, I sent it, it's under the review process, and when it is there in the review process, maybe it's accepted or rejected with minor, it's rejected, in that case it's rejected, maybe I got an email that it's accepted with major revision, or maybe it's under the review process. So, can I mention that on my CV first?
Yes. Yes.
If I can, after that, if the professor or maybe the organization, if they ask a copy of that paper, is it allowed to send? Because it is not yet accepted, it can get rejected, and in that case, again, won't that be a copyright violation of thing?
Okay, yes. Do we want to answer? I can take a stab at it. Okay, so you're right, there's another differentiation there. You can say submitted or you can say review. Sometimes people will say in the review process, which means that it's past the submission, we are now going back and forth. It may mean that to some people, it may not, but to me that's what that means. So, of course at all times send a copy, so we know that. It's all about work. Once you have submitted it to a journal, I would say you cannot submit it to another journal. You cannot, because that's the copyright violation. So you need to wait, or you can withdraw. You can say, right. I mean, sometimes people do that. It's taking too long. I don't have the time for this. I'm going to send it somewhere else where I'm going. So you can say withdrawing and then resubmit somewhere else. Before the drawing, to have it being considered by 2 publications at the same time, that's really not. That's very bad. That I would say.
I don't think that was
That was not the question, yeah.
That was not the question, but I think you were asking if you could send the manuscript to someone,
to some professor,
maybe a collaborator, or someone who might want to hire you, or something like that, right?
Yeah, exactly.
But if you do that, I think you should mark it confidential, because when it's under review by a journal, it's considered a confidential document, not to be shared. In other words, if I'm reviewing a paper, the editor will tell me, don't share this with anyone else, because once it's submitted to a journal, it's considered a document that is confidential. Until it appears in print, either online or in print, it's to remain a confidential document. You can, I think it's still okay for you to share it, but make sure whoever you're sharing it with that it's under review and it's to remain confidential. And be very selective about who you share it with. You have to be careful about your own work and to protect any, obviously if you're submitting it for dissemination in an open journal, you probably don't have intellectual property issues. But that's another thing to keep in mind before you submit to a journal. That's considered a public dissemination. And at that point, you pretty much have given up your intellectual property on any discoveries that are revealed in the document. So that's another thing. I don't know if prepared to talk about that, but
No,
need to
let's
keep-
talk about it now. As they come up, let's just talk about
Okay.
it. Otherwise, we might forget it some other time.
No.
Yeah, since,
When you submit for public dissemination, you better know what your intellectual property position is on the work, so that you protect your intellectual property. Okay. So.
And definitely draft everywhere. Confidential draft, something like that. So people know, but you don't want to take the chance. So on the paper you're sharing.
Yeah, I really want to just add the thing that you really need to let your advisor make that call about sharing it with various colleagues. Because the advisor is going to know if there's a non-disclosure agreement or what the intellectual property issues are or whatever. Please make sure that you do that, just to have it, regardless of your relationship with your advisor, if it's maybe not super great or whatever, just please give them the courtesy of having the final say on yes, you can or cannot share that with somebody that is, a colleague of yours and theirs in the field. That's really important.
This can actually extend beyond just sharing a document, because when I was a postdoc, I contacted a person about an issue and I didn't know they were a competitor. And they rushed publication into press and they beat us. So you have to be very careful, even describing your research sometimes, depending on the competitive nature of what you're doing.
So since we have a new panelist here, let me introduce Dr. Peyton Morrison. Peyton, you want to say a few things?
I'm a professor of chemical engineering here at Michigan Tech, and my field is non-Newtonian fluid mechanics, and also I'm a textbook author. I like to write really long manuscripts.
Multi-year manuscripts.
Multi-year. And I think we have a new student, and maybe we should have the student introduce himself.
Yes, please introduce yourself. Tell us your name, which program, and what year you're in.
Hello, all. First of all, I'm sorry for coming late. I had a class that just ended. So
No problem.
No problem.
We're happy you're here.
Yeah, my name is Adewale.
Adewale.
Yeah, I'm from Nigeria, and I'm doing a program on the social science program on energy and environmental management.
I
So I'm a
see.
PhD student.
PhD student.
What year are you? First year? Second year?
Yeah.
First year, okay.
Yeah, first year.
First semester.
We have quite a few students from Nigeria this year. Have you met the other Nigerian students?
Yeah, I see one.
I mean, compared to the last few years, this year we got quite a few students from Nigeria.
Yeah,
so welcome. We're happy.
We're ready to be made empty.
Wait till you see the winter.
I've seen it already. I was here in February.
Oh, okay. So
No, it's beautiful year round. It's either hot or cold, but it's beautiful. Okay, we can go. Okay, so why is it important that you publish? This is sometimes a question that comes up, and for me, before I even get into all of this, when you get a grant, there's a deliverable, and that is that you're going to generate new knowledge and you're going to publish it so the rest of the world knows about it. That's your first criteria, because sometimes our faculty will say, oh, I don't think I need to publish. Yeah, if you're rich and if you're, funding yourself for research work, that's fine. But most of us are using taxpayer money to conduct research. The taxpayer is paying us money to generate new knowledge to be shared, whether it's a new drug from NIH-supported money or a new thing about policy. It's not for me to do my research and sit on the data and say, I just can't be bothered to publish it. That's why you won't get another funding if you don't publish it, because we don't know what you did or if you did anything, right? So when it's taxpayer-funded money, I think it's an obligation to publish. That's my first point there. So yeah, it's as we just talked about it. We said it's to make sure that your science is good. Anything that you share is good. That you go through the peer review process, that is. So we talked about this. It's how we define our creativity, the body of research we have done, what our specialty is. It's a measure of our creativity and What is your measure to solve the ability to solve society's problems? All of that is what people are gauging at a different level. Yeah, this is an important one. When am I ready to write a manuscript? When should we start writing a manuscript? And so here are some points, and here also I think all the panelists will have their own say. So, does my data tell a story? Or are they just random pieces of information? We did all these experiments, this. Now, is there a story? How is it connected that I can talk to somebody about this as a story? You need to tell a story, finally. So, then, are the results that I have got, does it move the field forward? Am I adding new knowledge to the field? If you're repeating the work that someone else did without any new thing, that is sometimes it's a fine line here. You might have changed a few variables, a few parameters, but you have to ask yourself, is it significant new information? That's what the reviewers are doing too. When they send it to us to review, they're saying, does this manuscript add significant new information? Not just new information, but is it enough there to be published, right? So and that's what you have to ask yourself too. It doesn't mean it has to be earth-shattering, okay? And that's the mistake many young people make, including young faculty, that everything has to be an opus, a magnum opus. No. You have to be able to say, new information, is it relevant? Is there enough to tell the story? And is it enough that I can add to the body of knowledge that is already there? And sometimes, in order to get that, I tell my students, I'm saying tell, although I don't have any more grad students. Last year, my last one, 2 years ago, graduated. But when you think you're 50% done, I would say start writing. When I say start writing, I mean put the graphs, put the results section, and at least the data, whether it is table, graph, picture, schematic, whatever it is, however in your discipline you're presenting the data, start putting it together and say, what is the story that this is going to tell? What is it that I'm going to talk about? Because sometimes when you put that together, you realize, oh, I can go this way or this way or this way or that way. And which way do I want to go to finish the story? And as a junior faculty, I made the mistake. I would wait till there was so much work, then it would not be one manuscript. Then I would be telling the editors, I want to back to back, 2 manuscripts, all this stuff. So I was waiting till I had way too much information before I would sit down to write. And then it was almost too much. And after doing it 2 or 3 times, that was too much. I learned my lesson. No, start writing when you think you're 50% done. That also means what is 50% depends on which journal, right? If you're in chemistry and you want to send it to JAX, is it a communication or is it a full paper? 50% for a communication is very different than 50% for a full paper, right? Because you've read all those short manuscript, big articles. So where do you want it to go? And when is it 50%? Okay. Then it helps you also finish, because sometimes you wait till too long, you do this set of experiments, and then you realize, oh my God, that control over there I should have done, and I missed it. And now that when I'm telling the story, I realize there's some experiments that should have happened when the tree was just 6 months old, and now the tree is 2 years old, and I can't even gather that data, or the equipment is gone, etc. So it's really important to start crafting that story early. Okay, so that's what I used to tell my students. I'd say, yeah, start writing, tell me what you want to tell me when the story is complete, and then we can start publishing. You want to add? Okay.
Yeah, I think, but people think that writing is grammar and where the comma goes and not splitting an infinitive, but writing is thinking about what you want to say. So if you don't start, a lot of people will think, yeah, I know what my research is about. I know what I'm trying to prove. But then if you really press them and say, explain it back to me, they go, well, you know what I mean. I'm like, No, I don't know what you mean. You have to tell me what you mean. So the act of writing forces you to decide where the beginning is. Where's the beginning of my story? I have a vague idea of the end, but you don't know the beginning. That's the story that Dr. Murthy is talking about here. You know, like, where do I start to explain to a scientific peer what my idea is and what I think I'm about to show? And as you say, sometimes when you do that, you realize, oh, there's a big hole here. There's like something a little bit vague about getting from the beginning to the end in my story. And it's often, if you do that early enough, you can fill the hole. If you're doing it at the end, now you're in trouble.
Yeah.
Right. So
I can just add a little bit to what Faith said. You know, this writing is just a part of the continuum of doing the research. You know, that starts with planning, which might involve doing a lot of reading, which is actually one of the best ways that you can learn how to write, is to pick up and read a few good articles, okay, and then you can get a sense for what a good publication is all about. But the planning of the research, if you spend enough time doing the good background work and identifying a worthy problem to work on, and then you actually go into the lab or do whatever your research is to accomplish your objectives, then you're in a very good position to write, because you have a story to tell, you've done your good background work, you know that you're filling a data gap or a knowledge gap, and that's going to make the writing all that much easier, because you know you have something valuable to tell the reader. So yeah, I don't know if we're prepared to talk about the whole continuum of research. We're kind of at, the writing is sort of is at the end, you know, it's at the end of that continuum of work.
right.
But it's not separate from it, you know, it's all part of one big continuum.
Right. Yeah. So Jacob, make a point about that. Do we want to talk about, you know, research project from conception, from writing the proposal, carrying out the project, there, publishing, which is the last stage. Here we are focusing on the last stage publications, but that's an important point.
I'll just add to that one of the ways that I've found can be effective in developing a manuscript is to use presentations and posters as a way to lead into it, because it doesn't have to be as clean and neat and tell the complete story. You may have one central result that you really want to present,
Right.
and then you can stand and talk to people about it, and they'll ask you questions, and the questions that you don't know the answer to, those are the ones that help you. Oh, I gotta have the answer to that before I write this. And so when I send students who are working with me to conferences, I tell them, you will do a poster, because I want you to stand there for 2 hours and talk to people, because if you give a 10-minute presentation, sure, it's a higher visibility, and actually if they were interviewing for jobs at that point, then I would say, yeah, do a presentation. But if it's earlier, do the poster, because I don't want you to have 10 minutes and then it's done. I want you to have the 2 hours to talk to people as they come by, because then you can take that and use the poster as, you know, the first part of the manuscript, but then fill in the gaps that you've identified by talking to people.
Yeah, and that talking also fills what Dean Murthy said about not somehow allowing too much work to be done before you start writing. You want people to take it out for a spin. Let's see what they say about it, and then you can get the sense of when it's done by that reaction, and they may guide what you end up doing as well. It's a great opportunity.
Right. So with my students, I would often, as Dr. Cantrell said, use the poster sessions when you're like 50-60% complete. That's telling you to put it up in the public, right, in the public domain. And so let's say you have a meeting coming up in June, the abstracts for the meeting are due in February, let us say. And so about 3 or 4 months before, I sit down with my students and say, abstract is due in February, what do you think? You think you will have enough to present next June? That means mostly it should be done by February, but not completely, so long as you have enough. But what that does, this not only for me and my students, for everybody, is it gives you a deadline. okay, I better get these things done enough to submit an abstract, because if there isn't enough, your advisor will say, sorry, you can't submit it, right? And then once you've submitted the abstract, it gives you an incentive to really get much more done by the time you have, you have to make the poster and present it. Then you have the incentive and you have a lot of feedback to go ahead and finish it. So you need to line up those things in a way that really keeps you going. So it's good to go to your advisor, say, I want to send an abstract for that next year, so that it keeps you motivated.
One question here, as Professor just mentioned, say we are working on a journal, we are working on a big project. Now, is it a good idea to break them in small poster or small presentations beforehand and then combine multiple papers before going into a journal, or is it a good idea to complete the whole journal in 50-60% and then move forward for a journal rather than going for small papers and then?
Okay, so
On that, I mean, it depends on the project, and it depends on your advisor to some extent, and it depends on what you want to do. Do you want to have, so I would discourage breaking it up into what is commonly known as an LPU, least publishable unit. Because, then you can say, well, great, I got 20 papers out of this, but each paper is really small and not that significant. Maybe take 5 or 10, put it together into one really significant publication. How you break that up, it depends a lot on, how the project is progressing and where you're going to submit it. I think it's a conversation that you, your advisor, and your collaborators need to have.
Yeah.
I think it's good to keep in mind your goals. I advise my students to look at publishing 1 paper per year as kind of a benchmark. Hey, if you want to go to poster presentations and you want to do all this other stuff, that's all fine. But make sure you publish that 1 paper per year. I'm not doing it out of selfishness. It really helps the student, because those are the significant outcomes of your research that people really care about. Yeah, if you made 10 poster presentations, that probably doesn't match the importance of 1 significant publication. So, be prepared to prioritize your work in getting the best outcome for yourself.
Okay, so as we said, to some extent, you had a question. Go ahead and ask that.
Is it sometimes a good idea, say, I was working on a problem, I completed the project, and after say 1 year or 2 years, I found maybe some new ways to better that idea. So is it sometimes good idea to challenge my own work, own previous work, and then go for a new publication which betters my own research in some way?
That's called the scientific method. I mean, that's the purpose of research. You're not doing research to answer every question to come up with a final solution. That's not reasonable. I mean, we gain knowledge in small pieces, and when we do a research project, we probably have more questions unresolved than we've answered, and that's actually a good thing. That's the whole process of knowledge generation. If you're not generating new questions to answer, you haven't addressed the research in a significant enough way that there are additional things you found out that you don't have an answer to, that's not a good outcome.
But when you go, I'm going to answer a somewhat different question, which may or may not be what you asked. That is, you can go back and do the same experiment with better sensitivity or something, unless it is significant. Unless the new results that you're going to get is so significant, because technology improves all the time. Spatial resolution, time resolutions change all the time. Maybe you're looking at a brain scan and how it interacts with reading. You have this data, you publish 10 years later, 5 years later, you have much better equipment. If it's telling you the same thing, and if you go back and say, yeah, but look how much cooler it is this time. I have so much better spatial resolution. All of it is good, but then you're skating on thin ice. Then you want to be asking a different question. you can still go back and say, as we published 10 years ago in 2010, that's what this told us. But this is with the new equipment, you know, we could answer these other things or additional information. You just have to be tricky about when you say going back to do the same thing. I don't know what you meant by same thing, but you can't do the exact same thing. Yeah. Okay. Okay, so again, as we said, 50% done depends on the journal and whether you wanted to submit it as a publication, communication, full paper, whatever it is. So just be careful about it. Yeah. Okay. Yeah, you know, you have to become proficient in writing in English for most of us now. Most of us are publishing. As we already said, if the English is bad, they're going to return it to you. Definitely look at the scientific format and do it, and seek out and use any resources available. The grad school is looking at dissertation writing facilitators in the discipline. We'll be talking about to help you with the dissertation writing later on. When they say any resources, that's what you need. But what I would tell my students is, if you pick a journal and the paper you want to write, bring me 5 papers that are your top 5 papers in that journal. And tell me why you think it's good. Okay, so, oh, I like the way they framed the question, the abstract, or look at the way they presented the result. Just the idea of making clear to yourself what you think is a good paper in the journal you want to submit and why those things rose about, you know, that itself will tell you how you should be writing. So I would say that's a good exercise to go through. Pick people's papers and say why it's good, and then you know that's how you want to write it, right? Yeah. The other thing that people, students ask, and this it's not covered in this, is what goes into results and what goes into discussion. That's always a tricky thing for many. Some journals will say results and discussion and mash it up together, right? So that just takes you out of that having to figure out what is results and what's discussion. But most journals don't do that. So maybe we can talk a little bit more about the differentiation between results and discussion.
Mm-hmm.
You want to say something?
Well, I would say that you know, the results are pretty much, this is what I found. You know, refer to tables, refer to figures. The discussion comes in how you interpret those results. How do they compare with what was found before by other authors, and how do you position your new work in the light of the previous work, and how is it significant? So that's how you really, you know, do the intellectual work behind the research that you do, is how to interpret it. That's part of the discussion of your work, and it's probably as important, if not more important, than just repeating what the results that you found.
Yeah, I would also say that this issue of looking at the journal you're targeting and matching it. Some people might think, well, that's just a protocol that they do it like that, but there is something more intrinsic in the order in which you present your result, and because it's kind of a code. You know, the readers of that journal expect to find certain things in certain places. Papers are complicated things, and we don't usually read them like, I don't know, like a bedtime story from start to finish. We take a look at who wrote it and what the title is, and then we just look at every figure, like what figures are there, and see if we can figure out what the deal is, and we hone in on the things that are of particular interest to us to decide whether I'm going to read this thing at all. I mean, I got a lot of papers to look at. I'm not even going to read it if it turns out it's not on what I thought it was on. If I spot the figure that I'm looking for, it's like, all right, now it is a bedtime story. Now I'm going to read it in order. But if I have to first verify that the methods are appropriate and that they haven't made the big mistake that I know happens in this field, and I go right to the methods section and I read that. So it's very nonlinear how these. So if you put stuff in the wrong place, I am not going to find it. You know, so you have to figure out where people are going to expect to see the thing that you're talking about. Sometimes people go right to the conclusions. You know, sometimes they'll read the abstract, but sometimes people write bad abstracts. So you have to work with the people who you're talking to, And so that's one of the purposes for figuring out what the code is for the journal you're actually reading about. You know, this communications style that Dr. Murthy has talked about, those don't have all these sections because that's the standard for something that's a communication. It's like, get it out quick and just get in and out of it really fast. So that's a convention.
Yeah, even science, you know, the most prestigious journal for all of science, if you see, there are science articles, but there's no beginning, no end, no abstract, there's nothing written there. And then there are the full papers where, you know, all of this is detailed. And those ones without the sections are really tricky to write. They're difficult to write. So anyway, pick the journal that you want.
I'd like to add something to this. If you look at the handout on the table.
Yes, did you put those handouts?
This is, this actually has in chapter 4, it talks about story structure. And so the structure of a paper for Nature is really different than the structure for most journals, most journals would be opening, challenge, action, resolution. So that's a little bit slower to develop, and so a Nature paper reader isn't, you know, the journal isn't going to allow you to develop the entire story. They want lead, development, resolution really fast. And when you're picking up any of those really high impact papers, you better go ahead and download the supplement immediately, because the supplement is going to be quite a bit longer than the actual paper itself. I mean, it's not untypical to see 20 pages of details in the supplement. And that's really where a lot of the real information is, because you just cannot present all of the data in the main paper. Yeah, I think in terms of separating results and discussion, I've seen it done really well if you have a very sophisticated study where the results are fairly complicated, so you have to explain in detail how those results, you know, what they are and, you know, why they are the way they are and how you interpret them, and then later you actually discuss that. But I tend not to write like that. I tend more to write results and discussion kind of together, because I feel like as soon as you're starting to present some of the results, you need to tell people why that result really matters. And so it's going to depend a lot on, you know, who you're working with in terms of your co-authors and also the journal, but then also, you know, like what kind of, you know, manuscript are you writing? Is it a proposal or is it a paper? Is it like a disciplinary paper or is it a really high level paper like Nature, where there's really these expected structures that are very specific?
Right, yeah. Because as Dr. Mazzolini said, some which say results in discussion in some way are easier to write, but many journals will separate out results and discussion, and your reviewers will comment back and say, really, this should belong in discussion. Why are you discussing it and interpreting it in the results section? They will come back and say that. So just look at it carefully. It's a tricky thing for most people, I think, if you want to separate it, but if you write a few papers, you will really understand. Yeah, let's go on to the next one. Oh,
One question.
Yeah.
And is it possible to write the two elements on the same page or on the same line, discussion and result and discussion? Just like
Depends on the journal.
If you're not sure if you're
no,
gonna
you often.
It is safe to.
Often the paper, the journal in the instructions will tell you all of that stuff, whether they want it separated. The other indication is the other papers in the journal will tell you whether you should separate this or not. Or, as I said, depends on the structure. In the Journal of the American Chemical Society, which is probably our most prestigious journal in chemistry, if it's a communication, there is no separation. So if you decide to send your result as a communication, you don't need to separate it. However, if it is a paper you want to send it up, you will see definite sections where they want you to put different things. So you need to really understand the journal and the kind of paper you want to submit in order to get that level of detail. There is no, let me try this and will it work? No, I wouldn't take that path.
Well, every journal has author guides, so you should download those and read them very carefully in preparation of your article.
Yeah, they will give you great detail. author, right? So you have to
Lay out the
be
structure
very-
that they're looking for, even how to format the references, so it goes into great, how long your abstract's supposed to be, whether or not you have a conclusion section, so the author's guide is really necessary.
We're an hour in, so please get up and get some food, get something to drink. If you need to move around, don't feel you have to keep sitting the whole time. Okay. Okay, the order of authors. This is okay. Yes.
As the only content part, what I always feel challenging is how much and what should mention the abstract part.
Oh, we'll
So-
talk about that.
Okay.
We'll talk about that. What should be in the abstract? Yeah. That is a separate slide. So, yes. So the order of the authors on your manuscript. It really should be restricted to those individuals who have made substantial scientific contribution, right? That's the bigger word there, substantial. What does substantial mean, right? And that is a subjective call. However, they should have made substantial scientific contributions to the story that you're planning to tell. You know? Typically, students or postdoctoral research who perform the research are included because they have made, they've done the experiments that then told them how this problem is being addressed, right? Of course, your major advisor, professor, principal investigator, research director, they are the ones who are guiding you through. They may not have been in the lab doing the experiment, but they're helping in the interpretation, in the design, in the iteration, and often in the original idea itself. So therefore, in most fields, that's the case. In some fields, like in humanities, the students are totally on their own, which is they follow a different culture. So I'm not talking about that. I'm talking about more science and engineering fields where it's a group effort. It's very difficult to just go solo on these things, okay? So in some places, they say the head of academic units or institutions. This is more true in Europe, where the head of the institute gets the name on every paper. Sometimes they don't even know what the paper is about. That is not a custom in the US in most universities. You don't have to put the chair of the department or the dean of grad school on any of your papers. Yes, I know. But some European labs do have 1,000 papers to their credit, and that's because their name goes on every thing that came out of the research institute. It's not right. They have not made a substantial contribution. Getting money to build a building and to fund your research is not substantial contribution. They have to be involved in the science of it. That's usually, and journals are becoming more and more strict about this. They will say, tell us what each individual author contributed. What's their contribution to this paper? That's because these things happen and continue to happen sometimes. So this is the authors that should be included, and then the order of the authors is very. So you have to come to that agreement with your major advisor and any other collaborators, whether they're other students in the lab or other research groups that you're collaborating. It's not something that one can decide on their own. It's best to be transparent and upfront about it. Often the problem starts if two people we think have made an equal contribution, and then what you do. And some journals will allow you to say that both these authors, 1 and 2, made this equal contribution and write that, but some journal articles don't. So it really, you have to have an honest discussion. Go back one, please. Yeah. So they have to be all satisfied. And this has happened at Michigan Tech. Sometimes the people have sent out papers that all the authors don't even know that they're on. They think they're doing them a favor. And it's like, wait a minute, I don't know what you wrote about. How come my name is on this paper? Could you take it back when they realize it? So don't include names of people who are not contributed. This sometimes happens, and it should not happen.
That's extremely bad violation.
Yeah.
Because you can just imagine the most famous person in your field, you suddenly put them on your paper to give your paper a boost, and that's just, you can just see from that example how terrible that is. You're not allowed to borrow somebody else's name and prestige and put it on your name.
Yeah. So, and then sometimes you have a situation where first, should they be in the author list, the order of the authors? They have contributed something, but maybe have not made it as a co-author on a publication, but really you want to acknowledge their work. You know, they helped you figure out how to use an instrument. And you thought they were particularly good and spent a lot of time helping you teach them, right? Or some people will say, they reviewed my manuscript and gave me important feedback, right? Those things can go in the acknowledgement section. So the acknowledgement section, people don't, I think, use it to the ability that they can. There is the author list, there's the order of authors, there's the acknowledgement. And so think about where in that it belongs. So rather than not having a person who has helped in some way, but maybe not enough to be a co-author, not appear at all, I would say consider them putting in an acknowledgement if that is appropriate to say, yes, thank you.
Yeah, and be careful for yourselves about putting your name on other people's papers.
Yeah.
It's not always a good thing to be on a paper. Maybe you can tell somebody, if you're not really that sure about what they're doing, you can tell them, you can just give me an acknowledgement. I'm really picky about where I put my name. There are definitely instances where, you know, I'm a professor, so I teach students and I give advice to students, but I don't necessarily need to be on their papers. You know, I'm maybe not collaborating with their advisors, and that's fine. You know, I'm here to teach students, so I will never refuse advice or whatever, but I might not want to be part of the project. I'm really picky about what I put my name on, and you should too. Because if somebody comes along and says, hey, thanks a lot for whatever measurement, and I'd love to put you on my paper, is that okay? You're probably going to want to say yes, because it's, you know, it's kind of nice to have, especially a long list of publications when you graduate. But you need to be aware that you're responsible for all of the content in every paper that you have your name on. So be careful.
Yeah.
Yeah, including academic integrity.
Yeah. Yeah, so most universities, including Michigan Tech, you sometimes go and use an equipment in another person's laboratory, and they show you how to use the equipment, but their involvement in the research work is not substantial in the project. However, they let you use the equipment. They may even have given you some supplies and, you know, maybe help with a little bit of interpretation. So acknowledge them in the acknowledgement section rather than as a co-author.
So I would say this slide and the next one, we could spend an entire hour talking about it, and I'm not suggesting that we do that. But the point is, there are some gray areas with these issues. I'll just give you one example. Let's say you are not the one who teaches someone how to use an instrument. You took the data. Should you be on the manuscript? And in many cases, the answer is unequivocally yes. But in some cases, the answer might be maybe not. Because in my field, we do field campaigns. So we go out and we measure stuff in the atmosphere. Somebody sets up a meteorological tower, and they take the relative humidity, the temperature, and the wind speed for the entire field campaign. I use that data. Should they be on the manuscript? And my answer is no. That is routine enough that, I mean, I could hire a kid from Houghton High School to do that. And so that doesn't rise to the level of an intellectual contribution to the manuscript. I could also give you an example where someone, all they did is take data, but they're the only person in the world who could take that data. They are the only person who has the expertise to really do that. Should they be a co-author on the manuscript? Absolutely yes. So these discussions are not clear cut, and I think, I'm guessing one of the reasons Dr. Murthy has put these two slides here is to promote this discussion.
Yes.
Have the conversation with your advisor and your co-authors before you get to, oh, the paper's done. Who is a co-author on it? Don't have the conversation then, because then the conversation can be a fight.
Way before, And you know, sometimes on the basis of the story you want to tell and these tensions that might arise, you might even decide not to include certain data to tell your story. Sometimes. So just be careful. Yeah, it's a involved thing. So the next one. Yeah. What should be the order? Really depends on the field. In chemistry, in my field, biochemistry, if you're the main advisor, you're last. When it says blah, 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 A, B, C, D, and P. Murthy, that means that's telling them, okay, that's the person, right? But that's not true in other fields. What about well, in your field?
In a lot of disciplines in physics, it's the first author and the last author are the two most important people.
Yes.
But if it's high energy physics,
Yeah.
it means absolutely nothing because they're alphabetical.
Okay, that's right.
So they fought it out, and that's how they solved the
That's how they solved it.
Because in high energy physics, there are probably 100 authors or 50.
1,000.
Well, and plus it's impossible to determine.
Yeah.
I mean, it's impossible to negotiate.
It is really field dependent.
I've seen a mixture where, you know, if there's a lot of authors, maybe the first 10 are in the order of their contributions, and then the next 20 are all just in alphabetical order. So you got to look at the author list and kind of
That's right.
figure out what's going on.
That's right. Yes. So in chemistry, it is the last one. Then you know that that's probably the major advisor who's writing. But then the first author is the one who's made the most contribution, and then second, third, fourth. If you can divide it. Yeah, okay, this is your number 2, number 3, number 4. Otherwise, after the first one, I would say alphabetical and leave it there because I can't figure out who did more or less, you know. So the first, as Dr. Cantrell said, the first and the last are significant. After that, I don't know what the significance means. However, you're a co-author, that's good. That means you contributed a significant amount to this. So, yeah, it's last because we're a group of chemists who came up with this. But it's not true always true. What is it in your field, Dave? Do you have the main, first author, last author distribution? How do you do it?
Similar to what Will said, first author is typically the student who did the majority of the work, and the principal investigator or the faculty advisor is the last author. And then, I mean, we don't, in engineering, we typically don't have 100 authors. We might have 4 or 5. And so it would go in the order of contribution after that. And that's a delicate negotiation. That's all part of it. But in the end, I think everyone realizes their relative contribution. It's usually not a fight, normally. I mean, the majority of the cases, it's amicably decided. And,
well, and sometimes the choice of, I mean, if there's a significant chemistry part of it, you might choose that one of the papers would be chemistry focused, and then the analysis physics part might be the second paper, and you change the order of the authors so that the people who are more into the physics would get first authorship and the chemist moves down the list. So that goes back to starting early on the paper that you realize you've actually got 2 papers, or maybe you want to recognize these 2 contributions by first authorship based on topic, and that's going to structure how you tell your story.
Right. So you're right. Sometimes I've had 2 students working on a project, and I will sit down and say, what contributed equally? This paper, let's put this one. Next paper, you'll be the first author. So you divide it up so they both know that they're. Sometimes I've also put somebody as the second author who I think contributed the same amount, but when I write a letter of recommendation, I will say, even though this person is, because that's what they want to know, what's the contribution? Even though this person was second author, they contributed equally and could as well has been the first author. So there are other ways to let people know what your contribution really is. And it's good to have that discussion. Many faculty should come out and say that themselves, and I would say that, you know, yes, but when is the next paper coming? Because maybe it is after I got my job. So, well, within the levels of recommendation, I will mention that that is the case. So that's just the fair way to do it. So that's something. So really, the bottom line, all authors should agree on the order of submission. After submission, it's really messy. So that's what I'd say. Yep, the next one. Yeah, choosing the appropriate journal. Yeah, you want to submit it to a journal which has a high probability of being featured and published. You know, maybe we all want to publish in science. Really, it's not, the chances are low. So don't go for the high impact factor alone, although that is something that most people consider. So you want to use something, your research should fit in the scope of the journal, and it should reach the right audience, the primary membership. And my second or third paper when I came here to Michigan Tech, one of the faculty in biology, I was shifting fields. I was moving from chemistry to more biochemistry. And I was going to submit a proposal to NSF or thing. And I knew that it was going to go to the biochemistry division and not to the chemistry division. And this person gave me really good advice. They said, publish it in a biochemistry journal if you have the option, because your reviewers that says more to them than the chemistry journal, because they're the ones who are going to review you. So keep in mind who's going to read, which is the audience you want to influence, to impact with your publication. To me, that is more important than impact factor, but that's just me. Yeah. So look at which journal fits the scope. If it's not the scope, don't even bother. In fact, if it doesn't fit the scope, the editor or the associate editor will return it right away and say it doesn't fit the scope of the journal. And sometimes when that happens, sometimes the scope has changed from last year to this year, and that's happened to me too. When they said, but I said, but last year you were publishing this, and they said, yeah, we all met and we decided we were going to change the scope. So. And so I said, okay, well then, who should I submit it to? And they were very nice, and they gave me 2 or 3 other journals that I could submit it to beyond the scope, and you can have that conversation, and they can get, and many editors, you know, if the work is good, they want to help you publish, so they can help that. Yeah.
The only thing I would add is that. You know, try to choose the journal that will give you the broadest dissemination and the greatest impact of the work. So, you know, you might have a choice between a low impact journal that hardly anybody reads, but it's going to be easy to get your journal accepted, typically, or a more challenging, perhaps a more difficult to get into journal. But if you get your work in there, it'll be widely read and it'll have a bigger impact on your future. So I always tell my students to shoot high, and that's our goal, and we'll see if we can achieve that in the end. But that's always sort of the first step, is in that direction. Yeah.
Yeah.
If I can add something to that. So I mean, you've heard us give you a lot of advice already. Many of you have said you're at the point where you're publishing papers or you're thinking about it in the near future. When you get to the point where you have a paper, okay, I'm going to write this paper. You go talk to your advisor about it. Tell your advisor where you think you should submit it. Now that doesn't mean that's where it will be submitted eventually, but you know, give it some thought, because eventually you're going to be the one making the final decision. I mean, presumably your advisor is making the final decision now, but think about, you know, tell your advisor, this is what I want to publish, this is where I think we could submit it, and here's why, because that helps you to think about telling the story, but it also shows something to your advisor. It shows your advisor that you're progressing to a stage in your career where you're ready to go out and fly on your own, so to speak, which is the eventual goal.
That's right. So, and that's why sometimes when I was chair for the junior faculty, I would always say, get a paper out. Don't try to make it a full paper to JACS, the Journal of the American Chemical Society. That's many years of work. But the first paper is new assistant professor is telling the field, who know you only as a grad student and then a postdoc, that I've arrived, I have my own lab, I've set it up, I've finished a project, and I know how to start, finish, write, and send it out. And I have published now. So it is really from beginning till end, from starting of the lab. And that is the message that it is sending out. So, but you can't, after the first or second year, you better start writing some really substantive papers. But really, you should look at the goal. What is the aim of this? No matter what, you have to have a story to tell. But how long that story should be? Should it be a short story or a long story? There you have some play, depending on what you want to accomplish. Okay, next one. Yeah, so know your audience. Definitely, you have to look at the guidelines for authors really carefully. In fact, you have to print it out, highlight it, stick it on your desk so that you have it all the time. And the 1 or 2 papers that you really like in that journal, make copies and stick it on the desk and see, how did they really explain this? How did they address this issue? What words they used? So, because you get caught up in that sort of detail when you're actually writing. So it's really good to have a copy highlighted and put it on. Yeah, develop figures and tables. This is the first thing I would tell my students. All the results you have, it should be in a table, a figure, NMR data spectrophotometer, however it is you want to present your result in a full, complete form. I just want to see all of those pictures, and that's your real raw data in a way that you're going to present it, and then I will know, is the story good? Because sometimes, some figures, the error bars are way too big. It might be saying, go back and do that experiment again. This is not going to get accepted, or whatever. So the new raw data, you should take a look at that first. Okay? Then write an outline of your manuscript around the story. Of course, refine it multiple times to get increasingly specific. Write a draft. First, the data and results you have support the major conclusion, and then it will tell you if additional experiments are warranted. And we've kind of talked about that a little bit.
One thing I could add to the outline idea is if you're the first author in a multi-author paper, one of your roles as first author is to organize the writing, and you can do that really effectively with an outline. You don't have to write the whole paper. If you develop a good outline and you identify who's going to write which sections, and you set some deadlines to it, you've pretty much accomplished what you need to do.
Right.
And that's an important skill to learn, to how to organize a group effort like that. So, the outline is really important, not just if you're a solo author, but especially if you're a group author.
Yeah, and I have a situation where it was an undergrad who spent a semester in my lab, did some work, left, gone, was working for an industry, and we were putting the story together like 3 years later. And then we found that the student had generated the critical experiment and the data, which in this case was NMR spectroscopic data, nuclear magnetic resonance data. It's not something we could just make up or draw another figure. It really had to be bring the compounds, get the NMR data, and put it in there. And he had that. And so that became critical. So even though he had left, I said, no, not only is that critical, I'm glad we have it, and he did it in a good way, he needs to be an author on this paper. And he was thrilled, the student, 3 years after he had left New York, and said, oh, I saw my name in the paper, thank you. So, yeah, the pictures, the figures, the diagrams, the tables is very important in science to do that. Okay, next one. Okay, so yeah, this is the way I do it. So others can say, I always tell the students, read the experimental section, the method section, because you did the experiment, you know how you did it. Write the method section first to just get into it. And then the results section, because you have your figure, you have the table, you have the analysis data. So then write the results section, because that's what it's saying. I did this for this purpose, and this is the result, and here's how I do it. As we talked about, the discussion is one of the tough things. So I will not go into this till the results section is done.
Yeah, I want to add something to this. So I found this really great book relatively recently, which is by Josh Schimmel. It's called Writing Science. And this handout that I gave you today is actually something that was basically an outline that was prepared by another professor, Amy Bergen. She posted this online and on Twitterverse and everything, so I feel fine sharing this with you. But go and buy this book, Writing Science, because I think it's only like $11 or $15. And it's really short and it's lightweight. And the nice thing about that book is that every single chapter that you see here, there's like almost 20 chapters, actually has a few exercises at the end of the chapter for you to think about. So what the author does is he says, pick 3 or 4, I think maybe 5 specific papers which would be part of your literature review. And he also suggests that you have some that are maybe high end, high impact, and some low impact, and then the rest of them really in the middle. And every one of these chapters, whether it's the structure or energizing the language or whatever the chapter is, you're supposed to go in and find examples of those authors having done that. And the idea is that maybe some of them, especially the higher impact papers, the ones that are getting a lot of citations, not just Nature and Science, but other papers that have a lot of citations, they've done those things very well because they're very good authors. So definitely want to put a plug in for this. The book is not expensive, and if you really want to learn about writing or even improve your writing, I learned a lot in reading that book with my students last year. Definitely take a look at it. You can even get it for Kindle if you're into ebooks. So it's really wanted to mention that because it's, there's a lot of vague things here about, like how to write this or how to do that, and it takes a lot of time to really learn that. But the only way that, as a novice writer, as a new scientist, the only way you're really going to get that is really from studying the literature. And this is by far, because I have bought a lot of writing books. This is by far the single best book about actually how to structure papers and what kinds of things to do to get your work read. Because that's the point. Your responsibility as an author is to be understood.
So, and Dr. Mazzolini gets 50% of the royalties for that book she's plugging.
No, I was looking for a book like that when I was a student. I never found a book like that. It does not, it exists now. It did not when I was a student.
I was totally
I'm ready to buy it, though.
This was a good plug. That's what I wanted to say. Lynn, you really like that book. That is clear. That's good. Now I'll also go and buy it. So yeah, discussion. We talked a little bit about the discussion. So you can see we're putting the introduction after all this stuff, right? You can have a rough introduction, but really the final introduction, the results are going to dictate what you want to say in the introduction, right? Because in the introduction, you want to say, the field says blah, 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 blah. However, it raises this question, which is unresolved. Therefore, in this paper, I'm going to do X, Y, Z. And so that's why the results that you're going to present will decide how you're going to end that first introduction section. And people will say, you should be able to go from introduction to discussion. Okay, this because your introduction is saying, this is what the field is saying. We know X, Y, Z. We don't know A, B, C. I'm going to address A, B, C. And then your results are saying, here's the experiment that addressed A, B, C. And then in the discussion, it's saying, now, we said we didn't know this in the introduction. And now we are saying, okay, X, A, B, C. Now, here's what our results are saying is the scope of the field, right? So if people don't want to look at the results, and many will do that, they will look at their introduction and they'll go right to your discussion to say, okay, what have you contributed to the field? How have you advanced knowledge in the field? So you have to look at those two sections in that context. So we had a question earlier about what is an abstract. The abstract is, as it says, for the entire manuscript. That means introduction, the experiment, the unanswered question you're going to resolve, what is the question you're asking and you're going to experiment with, what are the experiments, and methodology that you're going to use, what your results said, and how it contributed to the field. Everything. The abstract is everything. Students make the mistake of looking at it as an introduction. It's not an introduction. The reader should be able to say, oh, you're answering this question. Oh, this is the methodology you used. Oh, this is what your results said. Oh, this is how you advanced the field. So everything is like one sentence, right? You can't just go into great detail because how big the abstract should be is often dictated by the journal. But it should tell the story from A to Z.
I'll say that the American Chemical Society has gotten really strict about the way they want an abstract written, and they provide examples.
Yeah.
Do this, do this, do this, and do this in this order, and make sure that, because one of the most annoying things with an abstract is you read it and you still don't know what they did.
Yes, exactly.
And so ACS has gotten really good about saying, if you came up with a numerical value, it should be in the abstract.
Right. So which are the abstracts in which the number is important and which in which it is not important? All that goes into your calculation, and how the abstract should be. And the reviewers will get back to you on those things. So they're supposed to help you make your manuscript better, right? They will say, in this one you didn't say that, the plant grew 100%. It doubled in size when you tried this pH, and it is very significant. But if it just increased like 110, from 100 to 110 or 20, maybe not. So I think when you put the numbers, as you say, which is significant, so all of that goes into, and that's the very last thing. Write the abstract after everything else is done, even after the introduction is done. Then the title. You can have a working title throughout. It's good. It kind of helps you kind of know where you're going. But it's finally at the end, it is the last thing that you do the title that comes out. So, any comments on the title from anybody?
One thing I can just add is that, when you start writing a manuscript, sometimes you're going to have writing block. You're going to sit there and you're going to try to think and you're going to try to write and nothing's coming. So, just like if you're planning to go out for a jog, you want to do some easy exercises first. So is there something easy that I can write to kind of get my creative juices flowing? So if it's writing the methods section, in a good way, that's probably the easiest thing to do. You might start with something easy like that, and then once you get going, then the harder things become easier. That's a little bit of advice that might be helpful.
Okay, so we have 15 minutes. So I'm doing some quick thinking here, saying what it is that I really do want to cover. Okay, and the other ones we're going to go through quickly, okay, some of the slides. The next one we'll go through quickly. Okay, do's and don'ts. Do include the minimum data necessary to support your claim. You don't have to include every experiment you did. If you did it 10 times, one representative is good, right? Do present your data in as concise a way as possible. Don't include redundant presentations. Do include appropriate statistical information, error bars, and all of that stuff. Don't include irrelevant or redundant columns or tables or sig figs in the paper, and make them legible with labels readable when reduced to journal size. Make sure you actually reduce it and see if it is still legible, because what you see on an 8x11 paper is not always what it's going to be like. Let's go to the next one. Don't produce figures containing a lot of blank space. You're supporting information, supplementary information. Dr. Mazzolini talked about that. So deciding what goes into supplemental information and what goes in the paper, in materials and methods especially, that judgment is useful. Don't include trivial or non-essential data. Sometimes, you might have spent a lot of time doing this experiment 10 times, but really all you have to say is one sentence in the text and you don't need to rewrite it. So, the figure, there is the figure, there's the figure caption, and there's the legend. So what goes in all of those three, look at it very carefully. What's the caption? Which should say, the figures should stand on their own. If I pick up your paper and I read the figure, I should know what you're talking about if I'm in your field, without having to read the whole thing. So the caption is very important. And people have a hard time writing captions. So look at some journals, some papers where the captions are particularly good and revealing. Some captions tell you the results. I don't like that because I want to interpret the result myself. They will say, pH affects the rate of growth of the plant shoot. And then they show these figures. And I'm saying, don't tell me what to conclude. The figure is saying the effect of pH on stem growth, or whatever it is that you are studying. And here is where the pH, look at the stem growth, whatever you did, you're figuring that in the legend. But so be careful what you want the caption to be. Then yeah, label the data points in the figure. Sometimes people will write the figure, and in the figure they'll start putting all kinds of things, and usually that's not a good idea. It just clutters the figure, decide what should go into legend. Let's go to the next one. Let's see. Okay, referencing. I think you're all really good at referencing because there's all kinds of citation software. EndNote, right? Everybody uses EndNote. Is that
No, LaTeX.
Late? Okay, all right.
Which, by the way, the university has a site license for Overleaf.
Yeah.
And if you use LaTeX, I highly recommend Overleaf as a collaborative platform.
Okay, okay. What do you use, Lynn?
Oh, I've gone back and forth. Recube is what I like now.
Right. Okay, so yeah, so the critical thing is this: your manuscript must include enough citations so you let the readers know that you know the material, but not so much that you have 100 citations for a 2-page paper, right? So you should be careful that you let them know. So that means you're picking and choosing which paper, which reference to use. Yeah, improper referencing, yes, you didn't show the important citations in your, especially the introduction, which is where you're saying, I know what the field is saying in the introduction, and every statement I make, I have to show the reference because I didn't just dream it out of thin air myself, and so you should cite it, but should you cite 100 papers in the field, or should you cite the most recent, or the most significant, most important? All that becomes important in how long the citation list can be. Yeah, general guideline is a citation is needed for any claim that you make. Okay, because you're not making a claim without somebody else having done the work and told you what to think about this, right? So, unless of course it is common knowledge, and my rule for that is if it's appeared in the textbook, it's common knowledge. If it's not in the textbook, then cite it, or cite a review. This is where the review articles become very useful because they accumulate a lot of information in the field, and they, with one citation, then you can cover a number of different things. That becomes useful. Yeah. So next one. And yes, language skills is important. There are all kinds of editing services. Give the manuscript to others to read, your supervisor, your team members, your collaborators, everybody else. And also sometimes somebody who does not know the details of your work because familiar with the broader field, but then you're asking them to invest their time in reading your paper and giving you feedback. So take them out for lunch or something and give them feedback.
In Pushpa, it's important to note that Michigan Tech offers some help for students in terms of writing. So if you can do the good job to technically communicating your work, then the Writing Center can help you with the grammar and the other things. But you don't want to hand them something that's of very low quality because it'll be a struggle for them to make it better. So do a good technical work, and then they can help you with the other formatting and other issues. And it's especially important for where English is a second language. And most of the students here are where English is not their first language, so don't hesitate to use that service.
I think it's actually interesting to be careful, you know, that you don't want to, I know that I'm looking around the room and I'm thinking that most of you are non-native English speakers, but you really don't want to spend inordinate amounts of time perfecting the grammar in the first draft, because that's going to end up being a time sink, and maybe some of that stuff that you've super perfected isn't even going to be in the final manuscript. So you really need to sit down with your advisor and, you know, have a discussion about, can I give you, you know, a first draft without perfect everything? That's really important. Some advisors probably aren't going to be very open to that. I think my advisor handled it quite well, where she just made margin notes and she would just scribble like not clear. And then I didn't really know why something that I was trying to convey wasn't clear, but we would have a discussion about it. But, you know, every advisor is going to have a little different way that they want to handle that because of their specific workload and also the culture that they've been in their training. So.
We're going to skip that one. I want to come to the cover letter. Okay, what should go in the cover letter? The cover letter is very important because the cover letter is telling the editors, associate editor, what it is, why this is significant, right? That's what you're telling them. You're, in a paragraph, you're telling them this was the unanswered question in this field, and this is what I'm addressing in this. So that gives you the opportunity to get that, but also it is used to identify reviewers. So those of you who are editors and associate editors and pick reviewers, maybe you want to say something before I add something, because you want to know what. So you can, in the cover letter, recommend reviewers. It's a good idea to do that. Okay? You can say, please, here's a list of 3 or 4 reviewers that you would recommend, because many journals ask you to do that. That suggested reviewers.
Some require it.
Right, you're right. Many require, but that doesn't mean they're going to pick every one of those. And so, yeah, name, association, email, phone number, and like 2 or 3 sentences saying why do you think they're particularly good. So that is a good thing to do. So that is in the cover letter as well. Sometimes in the cover letter, sometimes in the submission. So it's hard to say. Yeah. So then let's move on to the next one. So this is what we said. The authors can suggest reviewers, the editor selects reviewers, and the associate editor selects reviewers. They often look at what's your paper and select it. I think we're almost coming to the end, so let's wrap it up here now. Yeah, you can look at that in the, we would like you to sign. If you came late and didn't sign, I'm going to stop right now. Okay.
I have another one.
Yeah, that's right. So please give us, sign off, especially give us your email, because we will want you to tell us what you liked, what worked for you, and what was not useful, so we can make it better. Yeah. And I really want to thank you all for coming, and thank panelists, Dr. Lynn Mazzolini, Dr. Luke Cantrell, Dr. Shauner, David Shauner, and Dr. Peter Morrison for helping clarify things and giving them perspective.
Yeah, if you have any questions, we're available to help answer anything.
Absolutely.
Don't be shy.
So there is
Thank you.